Next session will be Future Generations of Polar Researchers in Sweden. And our next speaker is Professor Dag Avango, Professor of History at Luleå University of Technology and co-director of Arctic 5. Hi, Dag. You will present online.
Yes.
So we're happy to have you with us here in Lund University. The title of your presentation is the Arctic and Antarctic Center.
It is actually not. It is the Arctic 5.
Okay.
We have
then
changed that.
There is a change in the program.
Yeah.
Okay. Welcome.
Thank you. I would be happy to present the Arctic and Antarctic Center, but let's wait with that until later. So today I will give you the Arctic 5, which is of relevance for the theme of future generation of polar researchers in Sweden, because that is something that we want to contribute to with the Arctic 5. The Arctic 5 is a university collaboration between 5 universities in the Fenno-Scandinavian Arctic. So if we start north, it's the University of Tromsø. In Norway, University of Lapland. In Rovaniemi, University of Oulu in Finland. And in Sweden, it's Luleå University of Technology and Umeå University, who work together in this collaboration. And we do so in an Arctic region that is undergoing change. And as we have seen in many presentations here today, this is, of course, has to do with climate change, and climate change impacts on the environment and on people. But it is also about new and growing economies in the north. For instance, in the extractive industries, where we have a very rapid growth in mining that has started in the early 2000s, and with some ups and downs has continued to increase due to metal demands in growing economies elsewhere in the world, and also the need for green energy. And this growth is global, of course, but it has had a northern direction in northernmost Europe, with increased production in old mines and increased exploration for new mineralizations and new ore bodies, and of course the opening of entirely new mines in various stages that are going on. And another part of this global trend affecting our part of the Arctic is also the new and growing economies, in particular the so-called green industries, where we have in northern Sweden several initiatives taking place right now with the battery production in Skellefteå, the Northvolt, iron sponge and green steel industry based on hydrogen gas, which several initiatives, the Hybrid in Gällivare, the H2 green steel in Boden in northern Sweden, but also new production units for artificial fertilizer and the extraction of rare earth elements from mine waste. And there are several green industry projects like this going on also in northern Finland and in northernmost Norway. And coupled with these new industries, there is also an increased need for green energy production, because in order to produce hydrogen gas, you need a lot of electricity. And this electricity, the investors in these companies wants to have renewable, which means wind power and possibly hydro. This is also a region that had a long history of extractive industries, of forestry and of fisheries already from the early modern period, and with a rapid expansion from the late modern period from the 1880s and up until today, which has resulted in the construction of these huge systems for extractive industries, mega systems, that also provides basis for the new industries happening. And this has, of course, meant a big growth and a lot of benefits to society, economic growth, infrastructures, settlements and services constructed, but also a number of challenges, transformed environments and various cumulative impacts on local livelihoods, not least Sami reindeer herding. With new infrastructures and extraction places interfering with reindeer husbandry, also in combination with the impacts of climate change on the snow cover. And so all of this situation brings new tensions over land use between resource industry and local actors who are using the land in other ways, and residents with opposing views on the future. There's also conflicts between sustainability goals and also an important challenge of making it possible to build these new economies, because they require personnel, and that means a necessity to create communities and settlements that are able to attract people to move up north. And the Arctic 5 universities are situated in the middle of this big process of change. And together we have over 90,000 students. We have some 10,000 researchers and teaching staff. We have research infrastructures, including not only the universities, but also research stations. And all in all, this is a great knowledge hub about how to deal with the challenges coming out of these processes of change. So how do we do this then? Well, our collaboration formed in Oulu back in 2016, something called the Joint Arctic Agenda. And from 2017, we started to call ourselves the Arctic 5. And the aim here is to advance and share knowledge and education and innovations in support of a sustainable Arctic. And the main fields of activity then is research collaboration and also joint efforts to build education programs. And in the beginning, we made this collaboration in the format of 6 thematic areas, where education was one, energy, health, mining, regional development, and indigenous issues. But since a little more than a year back, we have started to launch an entirely different model for collaboration, which in the format of something that we call the Chairs and Fellows Initiative. And this has been a way to build on already ongoing research initiatives taking place in different good research groups at our 5 universities, and very often in collaboration with other universities outside of the Arctic 5 collaboration. And our intention was to build on these already ongoing collaborations and make them grow into larger collaborations with more funding accessible and with more impact. So we launched the Arctic 5 Chairs initiatives, which meant that these leaders of these research groups were able to apply to become Arctic 5 chairs for a period of 2 to 3 years, with a time allocation of at least 20% of their positions and an annual travel and meeting budget for some 10,000 euros to build new research collaborations and to build new projects. And they are up and running, and we are following this up with another initiative that we will launch in the early next year with calls for applications for the Arctic 5 Fellows, which is meant then to stimulate initiatives and collaboration between emerging scholars, early career researchers, to support their growth into mature researchers with international networks in Arctic research. So the Arctic 5 chairs that we have up and working are the following ones, and they are working on a number of projects with a slight emphasis on social science and humanities field. So we have it in Luleå, Kristina Allard, Carolina Parding, and Agatino Rizzo, who are working on land use issues, on how to create sustainable communities in the north, and Arctic settlement planning and architecture. We have San Sebastian Miguel, Janina Pribe, Hans Pettersson, and Malcolm Lillier at Umeå University, working on different projects dealing with new global sustainability transformation or preservation in changing environments in terms of archaeology. At Oulu, we have Mervi Heikkinen and Anastasia Emelyanova working on projects on Arctic feminisms and on human-environment relationships. And Outi Rantala and Tanja Joona in University of Lapland on green transformation and the just green transformation. And finally, at Tromsø universities, we have Torjer Olsson leading an initiative for institutionalizing Sami research and education. We have Gunhild Hogesen working on disinformation and security issues in the Arctic. Inclusive Arctic education, George Gregor Maxwell and Alan Hubbard finally on Arctic Rainmaker, which is a project on climate change in the field of natural science. If you want to know more about the Arctic 5 and how to get involved with us, visit our website or you send an email to me or call me. So thank you.
Thank you very much, Dag. I come up to Luleå the other week now. As you know, our secretariat is located in Luleå, and we have our office at Luleå Technical University. So I bring here this cap to you. I will take it with me next time I go up in a week or so.
Thank you. I look forward to that. It's starting to get cold up here. So
I saw that on the map, actually. Okay, is there any questions for Dag here from the audience? No, I cannot see that. Okay, we are looking forward to hear more about this and see how all the nice outcomes that will come from the chairs and so on. And next time, perhaps you will present to us the Arctic and Antarctic Center.
For sure.
Yeah. Okay. So thank you for joining from Luleå, Dag. Okay.
Thank you.
Yeah, and welcome to continue to listen if you want to. Bye bye.
Thank you.
Bye.
Bye.
Okay. The next presenter is Cheryl Nyström. Cheryl, hello, welcome up. Cheryl, you are the coordinator for the graduate research school ClimBEco at Lund University.
Yes.
And the title of your presentation, if I am informed right, is the ClimBEco Graduate Research School at Lund University.
Simply that.
Yeah,
yes,
exactly. Fine. Okay.
Yeah, thank you. This is for me, yes. Good. Okay, great. Thank you so much for inviting me. I'm happy to take part. And I think it was a good segue, actually, between what Dag had presented and what is coming after me. That is what the PhD students are doing. Because what I'm going to present is the forum that is available for PhD students to, I mean, as Dag was saying, they have interdisciplinary networks, even as you continue along your research career. That's something that we start with already at the level of a PhD student. So, yes, my name is Cheryl Sjöström. And since a few years back, I'm driving the bus of the ClimBEco Research School. So I'm just going to tell you a bit about who we are and what kind of activities we do. The acronym had three big capital letters, and that is the combination of climate, biodiversity, and ecosystem services in a changing world. So those are the sort of umbrella concepts that PhD students, if they're working on anything within these concepts, they're very welcome to ClimBEco. And we do not hire PhD students ourselves. It's rather, if you're already hired as a PhD student, you can come to us during a period of 2 years. And during those 2 years, we intend to be a platform for meeting and discussing or disciplinary boundaries. And of course, I think as a PhD student, it's a very important time to be able to actually relate your own work to bigger processes, say upwards, but also horizontally. So look, what are other PhD students doing in a similar either geographic area or similar topic, but maybe coming from a different discipline? So it's situating one's research, and also we offer different mechanisms for supporting communication, personal and career development. I'm going to throw out some acronyms here. And I think if you don't know the acronym, you don't have to know it. But if you know it, it's interesting to see that they are also part of ClimBEco. So we are supported by and thus help the mandate of the university, Lund University Faculty of Science. That's one of our main sort of benefactors, but also, and I say very importantly, to situate ourselves, it's the strategic research areas MERGE and BEC. And what they stand for is below, and like I said, if you don't know them from before, then that's okay. But also within these sort of contexts of climate, biodiversity, and ecosystem services. And we've been around since 2010. I say we. I've been around there. I've been working with ClimBEco since 2019, so it's older than me. But since 2019, it's been myself and my colleague Ylva who are working at the sort of main office, you say, and we're at the Center for Environment and Climate Science here at Lund University. We both have research backgrounds from different places, but together we're sort of helping to create the activities within ClimBEco. I'm going to get to what the actual activities are, because it sounds very fluffy so far. But of course, we are supported very much by a steering committee. And I don't think I have to go through the names, but if you know the face, it's a good start. It's this, obviously, we need the direction. What are the things that are important? What is at the forefront of these research areas that ClimBEco should be supporting PhD students with? So we have a steering committee, and they help us with sort of basically the bigger direction and deciding on things in the budget and in the operations. So yeah, nice friendly faces. And what is it that we do offer? During the 2-year period, we do ask the PhD students take at least 2 of the courses that we offer and take part in the annual meetings that we offer. But just looking at the courses, we do have both the sort of general courses, science communication, what is interdisciplinarity, looking more at the understanding the ontology and the epistemology of what is it that we're talking about when we're talking about science production. But also a little bit more about specific. It could be about introduction to R, or the ocean's role in climate system on geological timescales. This is I just picked a couple of the courses that we offer, but it's something like 6 to 10 per year courses that we offer. Besides courses, and I should say something about the courses also, I think what we do, of course, the course can be offered from any individual department, but what we do is try to bring in a teaching team which is interdisciplinary in themselves. So that's also quite nice. Or maybe a teacher from a certain institution says, well, this is a little bit out of our scope, so I need extra funding to be able to give this course. So that's where we also step in. So besides the courses, it is our annual meetings. We have 2 per year. And the mentoring program, that's where we have this sort of career and personal development part of the program. We put quite a lot of effort into that. As we all know who have been in academia, it's a beautiful thing to have a mentor, and also when you are a senior to be a mentor, right? There's a lot of learning to be co-learning to be done there. We also offer joint PhD seminars, and joint in the sense that it's a collaboration with not only ClimBEco, but other similar interdisciplinary sort of spaces, where it's by and for PhD students. So seniors are actually not allowed there, so that there's this sort of space between PhD students to present. And then the rest is additional things. If something comes up, we would like to visit this place, or this senior researcher is here, can we create a seminar around them being here? Okay, so we can basically facilitate extracurricular activities. It's quite fun. And some in the audience here. And in the spring, we attended the Swedish Climate Symposium in Norrköping. Is anyone from Berlin here? Maybe we have a strategic collaboration with the research school. It's like our sister research school at Berlin, and had presentations. They read each other's papers, a couple of students, and then we went and climbed in the trees and swung from the trees in the space outside of Norrköping, also for the networking side of it. So that's also a collaboration we are happy to continue developing. And then, so basically just a couple of faces, obviously not all, but currently we have, so we take on as many as 20 PhD students per year. It's not always that there are 20, I see some alumni here. And currently we are from 3 universities, so it's through the merge and Beck. So we are in Lund, but obviously I'm saying 3 universities. It's Chalmers and the University of Gothenburg, who we also can take PhD students through the SRA collaborations, yeah? And from different faculties and different departments. So if we take the concept, or the, like Dag was saying, I mean, you can work in the Arctic, but some are looking at the permafrost, and others are looking at, aerosols, and someone else is interested in, you know, you can look at the same geographical space and actually learn from speaking to other people who are also in the geographical space, but asking totally different questions about it. So that's something that we are very happy to be able to provide. It's a dynamic space, so we do have a few solid points. We always are doing some courses. We are always doing the annual meetings, but quite fluid otherwise, and being responsive to both the research environment itself, what is important right now for us to focus on, but then also the interests of the PhD students who are taking the research school at the moment. What is interesting for you? So with that, you can find out more at our website, and happy to answer any questions if there are any. Otherwise, I wish the coming PhD presentations good luck. What was it?
Thank you, Cheryl. So inspiring presentations. It's great for me as a West Coast person to hear that Chalmers, Gothenburg University, and Lund are working together in this successful way. Have the research school been to Abisko?
We have a course there.
Yes, maybe you said that. Sorry.
That one wasn't on the, but that's actually in discussion for 2023, if we because it's been cancelled because of the pandemic the last few years.
Yeah.
But,
I think I heard about it.
Yeah.
Great.
Yeah.
You're welcome. Okay, and is there any questions for? I think everybody wants to make another PhD if they have not done it before. Yeah. At least mine.
Yeah. Exactly, right? I didn't
hope I could repeat it.
Support this partly because I was part of EU Young Researchers Network when I was a PhD student in Iceland, and that's actually my question to you. Do you have any collaboration within EU as well, or this is mainly solely a Swedish network?
Again, that's maybe where the boundaries are not so hard, and it's not. It's nothing right now that we have. Like, we haven't applied for funding outside of the EU. A very recent development is that against an enrollment fee, we are opening up for other European PhD students to come and take part. That's something that's new, but otherwise, it's not. Actually, no, we don't have mechanisms to collaborate in the EU. Actually, no, not now. Yeah. Thanks.
More questions? No? Okay, Cheryl. Thank you.
Oh, this is perfect timing. Thank you so much. I was going to complain about how cold it is in Lund and hope you're enjoying it, but I know it's the wrong crowd to complain about the cold.
We are used to it.
Exactly.
Okay, thank you very much.
Thank you.
And good luck with the continuation.
Thank you.
Now we will have elevator speech by PhD students working with polar research. And we have here, I think it's 6, Melina, help me, 6 students coming up. First one is Christopher Cockerill from Stockholm University. Hello, Christopher.
Hello.
Arctic for genomics. Yeah.
Okay.
Did I get it right? Yeah.
Yeah.
Almost.
Pretty much. Yeah. Hello, everyone. So my name is Chris Cockerill. I'm a PhD student at Stockholm University. So I am part of the Swedish Arctic Fox project. Our aim is to really understand the processes that are ongoing in the Fennoscandian Arctic fox, so the Swedish side of that. My PhD is looking at the evolutionary history and genomic divergence of Arctic foxes. Our most recent research article was published 2 days ago, which was based on my master's thesis. So in this paper, we look at genomic erosion in the Fennoscandian Arctic fox in relation to the much larger populations in the east in Russia. So as Love actually described perfectly earlier, genome erosion. So we found extensive genome erosion in the Fennoscandian Arctic fox, and basically inbreeding and genetic variation decreased towards Siberia, suggesting that there is very little gene flow between between the populations. So if you want, you can take a look at that paper. I would certainly appreciate, and I suggest you do that. So for my PhD, so apologies for this photo. This is a farmed Arctic fox from Finland. So for over 100 years, there have been farmed foxes selecting the Arctic foxes for extensive skin production so they can have a higher yield of fur. So we have had some escapes in Sweden. Some escaped, some were released by activists, some were released when the farms were closed down. So we have detected some signatures of hybridization with the wild population. Now, if you take a look at this fox, yeah, it's going to come with some fitness consequences, right? So this is definitely problematic. I'm going to take a genomic approach to look at the actual extent of integration in this population and potential fitness consequences. I will also take a look at the actual evolutionary history of the Arctic fox. So if you can take a look here, you can see that we've estimated that the Arctic fox had a soft speciation around 200 to 500,000 years ago. Now, this is a very recent speciation event, and I'm going to use genomics to take a further look into that, whether there's ancient introgression happening, whether it's speciated from a temperate ancestor which was isolated in local refugia in the Arctic, or whether it was derived from a cold adapted species. And I will also take a look at how the Arctic fox has responded to climate change in the past. So I've got some ancient samples from the middle to late Pleistocene over at CPG from Center for Paleogenetics from Leuven. So I'm going to take a look at those samples. So they are ancient samples from Pleistocene Europe, Central Europe, in comparison to the modern day populations in Scandinavia and Siberia. So I'm going to see whether the populations were able to track the habitat as the ice shelf retreated following the last glacial maximum. Yeah, so with that, that's my project. I'm looking forward to all the collaborations I'll be making in my PhD. Hopefully lots of more field work. And that's it, yeah. Thank you very much.
Okay, thank you, Christopher. And good luck with your research.
Thank you very much.
Questions to Christopher? No? Okay.
Okay, thank you very much.
Next, George Victor Emmanuel, and you are a PhD student at Uppsala University, and you work with the waves MIZ numerical models. Yeah.
Hi, hello everyone. Yeah, you can see it's actually describing my past work, but I'll pitch myself first and then briefly skim through this. So as you can see, I'm a PhD student working on parameterization of air, sea, ice, wave interactions. It's a complex thing, I can swear. So modeling of these interactions is a complex thing itself, but parameterizing those modeling parameters, that's even complex, I can swear. So here in the first part of my study, what I did was I found a gap which is I can say very complex or very serious as far as a physical oceanographer is concerned, which is that the decay of waves in the sea ice covered regions was thought to be exponential, but it was not actually exponential, it was linear. There are, in fact, contradicting studies also found, but we were not clear why those contradicting results were, or the contradicting observations were there. So I did some sensitivity analysis with this model and had some conclusions. My conclusion was the models generally didn't take in account for the wind factor. That's the reason. So keeping aside those things, I can say about myself a bit also. So as you see here, parameterization is what I am into. Here, I looked at the source terms of waves. The steps ahead, I look into how the sea ice concentration or the sea ice distribution works, then the sea ice thickness works. So it involves how the the near surface winds are generated and how these near surface winds eventually contribute to the waves and how these waves actually contribute to the breaking or drifting of ice, those parameters. So it's basically those things. Now, here are some interesting results from my last work. As I said, ice. So the breaking of waves or the decay of waves happened because of the ice. That's quite understandable, I guess. But interestingly, the effect of wind also is very important, which we previously thought is not very significant. But this, probably this figure, the one, the bottom here, will explain itself. Like with increasing sea ice concentration and increasing wind speed, with decreasing sea ice concentration and increasing wind speed, the effect of winds are more prominent or evident. So that is what the key update is. So we need to update this thing in the models as well, and hopefully we get to have a better modeling also. Yeah, that was basically it. Thank you.
Impressing. A lot of results already.
Yeah.
Yeah. Do you think your parameterization, will it have an impact to improve gas exchange models for, for gases that are distributed between sea ice and the atmosphere? Because that has been very tricky to model before.
In a long term, I should say yes, because this is just a first step.
Yeah.
Because with this thing, we can have better modeling of waves, which eventually, I guess, maybe a coupling of things can eventually lead to these gas exchanges.
Yeah.
Yes.
So thank you very much. Just a second.
Thank you.
Not an ice cap, but a cap.
Serve me, I guess.
Okay, thank you. Is there any questions? Questions? Yes. Wait, Victor, Emmanuel, come back.
Oh, sorry.
No. Sorry. George, Victor, Emmanuel. Yeah, George. There is a question.
Oh, sorry.
The data you are using for your modeling. Is the source of your data?
So the data. So it's from the American cruise, which they conducted it on 2015, I guess. Yes, 2015 October.
But for which location?
In the Beaufort Sea.
Okay. So thank you.
Alaska, near their region. So they have the data that was covering, I can say, close to 10 degrees in latitudes. Not 10th degree, I'm saying 10 degrees of latitudes, and yeah, similarly around 10 degrees of longitudes as well.
What about the location like closer to Sweden, like Bay of Bothnia and so on?
So, yeah. Are you asking if my results are actually valid to all locations? Yeah. Okay, that's what I mentioned. Maybe a small word was there. So there have been contradicting observations in my case. Like there are some results which say that there is exponential decay of waves in the ice. There are some results which say that they are linear. But that's where my research actually fits in. So this exponential decay is replaced by linear decay when there is high wind input. Say, in the case of an extreme wind, like a cyclone or a polar low, whatever. So it's applicable to every location.
Okay, thank you very much.
Mm-hmm. Thank you. So from waves in the marginalized zone, we go to air-sea interaction, the polar law. And welcome Ting Lin, PhD student from Uppsala University.
Yes. Hi everyone, my name is Ting, and I'm a PhD student from Uppsala University. And I'm working on the impact of air-sea interactions on the polar laws. And so first of all, here is the definition of the polar law. And the polar law is a maritime polar scale cyclone, which only occur at the polar regions, and its horizontal scale is usually smaller than 100 kilometers, and its time scale is usually lasts for 3 to 36 hours. And during the polar development or evolution, it's usually accompanied with the stronger surface wind and heavy precipitation and the snowfalls. So when the polar may landfall, it would cause damage to the coastal communities. So that's why the meteorologists concerned about the polar laws. So the figure on the right shows polar exactly looks like from the satellite image. And in my PhD project, I'm more concerned about the ocean's impact on the polar laws. So in this study, it's for the sheet wave impacts on the polos. So the sheet wave is the kind of water vapor produced by the wave breaking. You can see from the picture with the bottom here. So during this process, it would have momentum flux and heat flux exchange in the boundary layer at the S interface. So my study question is so here I want to know, does this wave have impact on the development of the prologue? And now here's some results I get so far. So for this study I have done, I include sheet wave parameterization into the atmospheric couple model and to see the sheet wave impact on the prologue. So something has to be clear here is for the pole research polos, communities used to classify polo by reverse polo and the forward polo based on the thermal wind and the real wind directions. So here's some result I get here. So from the figure on the right shows some parameter which is usually used to quantify the intensity of polo. So the result I get from this study is here. So I know the sheet wave would have more impact on the reverse polo, but they don't have the impact on the forward. And then the convection is the reasons how the sheet wave impact the polo. I think that's it. Thank you.
Thank you very much. You also have already very interesting conclusions on your work, so good luck with the continuation. Questions? No? Just a minute, a second. Cap for the polar lobe. Thank you, Lynn. Okay, then we have Cas Renette, PhD student from Gothenburg University. Welcome. Palsa mire dynamics, degradation and aggradation through remote sensing, drone, LiDAR and satellite data, geophysics, internal structure analysis and the corresponding relations with climatic and environmental factors. Wow.
I think that was supposed to be the description and maybe not the title.
Yeah.
Yeah. So hi, I'm Cas from Gothenburg University. I just started my PhD 2 months ago, so I'll mainly say what I will be doing and don't have that much results yet to show. So what are pulsars? So pulsars, we've heard them today already a little bit. They're peat mounds with a frozen core, and they are generally found in subarctic wetlands, like in northern Sweden, and they can exist thanks to the thermal properties of peat, where dry peat in summer is a great insulator and can protect the ground, keeping it relatively cool, and wet or frozen peat in autumn and winter is a great conductor of heat, meaning it can cool the ground effectively, and then form an ice core which could survive the following summer. So why is it important that we study these? Well, first of all, they are a marginal permafrost landform, so that means they exist close to the southern border of permafrost extent, and therefore very sensitive to climate change. And over the past decades, an increased rate of lateral degradation has been reported, and it has been explained earlier today that if we go from this higher elevated pulsar to a more fen-like or thermokarst environment, greenhouse gas releases increase, such as methane. And we have limited knowledge about the internal structure and volumetric changes actually on these pulsars. So my study area is then the largest pulsar mire complex in northern Sweden, which is called Vasiola, and I'll just focus on 2 individual pulsars, a more ridge-shaped and a more dome-shaped one. So my main objectives are then to get seasonal and annual volume changes of these pulsars, to map the internal structure, and to determine the associated environmental and climatic factors related to the pulsar change. So what I've done so far, I have been lucky enough to go up once in September, the same week as I started my PhD, and we flew a LiDAR scanner on a drone to get very high resolution elevation data. So we have done that once, and we've set up a weather station in a close by area. So the elevation data have not been completely processed yet, but I can show you a first idea of how these two pulsars look. So they're definitely prominent in the landscape, and this is just the first time, and we plan to fly many times more. And both of these pulsars undergo lateral degradation, so the formation of these thermal karst lakes and block erosion features have been found. Regarding vegetation, the dominant vegetation are shrubs. On both pulsars, actually, dwarf birch and crowberry are most prominent. And on this ridge-shaped pulsar, which is also the background photo, actually, there's a lot of cloudberry and some larger birch trees that we can see. Which are also found on the digital surface model there, but we're planning to get a digital terrain model to get the elevation of just the pulsar terrain. So what's up next then? First of all, lots more LiDAR scanning. We plan to go up 4 more times in the coming year to get see if we can get a seasonal elevation of these landscape features, and later, of course, annual volumes of these pulsars, so we can see how that actually changes. Then we'll start measuring ground temperature, so we'll install boreholes and do some systematic active layer probing, which is the layer on top of the permafrost, which thaws in summer and freezes again in autumn and winter. Then we'll do geophysics, so ground penetrating radar, to get a better idea of the internal structure of these features, and we'll take some cores as well, which we can analyze in the lab, where we will look for ice microstructures to identify maybe melt pathways or those kinds of features. And then if I get a lot of data, hopefully, you never know when doing fieldwork in the Arctic, then I'll try to use this data to use a permafrost model to maybe predict the fate of these beautiful features, which I don't think is a very positive future for them. But so not so many results, but lots to come up.
Thank you, Cas. I think it's extremely impressive. Did you say that you started in September,
Yes.
2.5 months ago?
Yes.
And already ready for these presentations and the planning and everything? I think this is really impressive. Thank you, Cas. Questions? No. Yes, that, yeah.
Hello. I'm really curious about this LiDAR project technique. Like, I wonder, like, what's the resolution of this one? And as I know, maybe I know something wrong. It's LiDAR cannot penetrate the canopy, right?
LiDAR can actually penetrate the canopy, and that's why it's such a great technique, and that's why it's fantastic that we can put these on a drone.
Oh.
Yeah, we have a bit of a struggle with a company which is going to process the first time and then teach us how to do it. So these results, you can see still the trees on on this ridge-shaped pulsar, but we actually do penetrate the canopy, so we can just get the surface layer. So that's.
So you will get data from both the canopy and the floor.
So actually you get the vegetation, and you get actually just the ground surface, and I'll be most interesting in the ground surface, but we can also look, of course, on vegetation heights and if those are changing, and that's why LiDAR is such a great technique.
Sorry.
Oh, and the resolution.
And any height limit of LiDAR, how high you can release your drone?
No, we're mostly restricted by rules, EU and Swedish rules for drone flying. So we can fly at a maximum of 120 meters high, but we flew this at 30 and 60 meters. And you also asked about the resolution, and it's extremely high. So right now, usually if you have 10 points per square meter, that's already considered as a decent resolution, and we now got more than 1,000 points per square meter, which is maybe excessive, but then we'll know for next time, so we can be a bit more saving with our battery.
It's really cool. Thank you.
Yeah, I must say it's really cool. Yeah. Cas, thank you so much, and good luck with your continuation of your research. Thank you. Whoa. 2 caps left, and 2 PhD students from Luleå University of Technology. So we start with Vasiola Zhaka. Welcome up. And your presentation is level ice and brash ice growth in Bay of Bothnia.
Yes. Hello, everyone. I'm so glad being here. My name is Vasiola. I am a PhD student in Luleå University of Technology. And the last 2 years we have been doing research on sea ice growth in Bay of Bothnia. So our research have 2 main aims. The first aim is to investigate the snow effect in brush ice growth in frequently navigated ship channels. And the second aim is to investigate the snow effect in level ice in the vicinity of this ship channel and adjacent to the ship channel. As you can see, I don't know if it's... Okay, the green square shows where we have been conducting the field work the last 2 winters. So we have been investigating the main channel, or what we call the main channel, is a frequently navigated channel who have access to Cementa port and also Icebreakers port in Luleå. And next to it is a tinier channel which have been formed only for testing purposes from tag Viscaria. And here you can see the differences between two channels. The one to my right is the testing channel, and the other one is a frequently navigated channel. So almost 3 to 4 days a week we have been spending on ice, measuring the thickness of both channels along the cross-section, and also measuring the thickness of ice in the vicinity and also a little bit further to the side of the channel. So what I'm showing here is just a simple levelized core taken from Bay of Bothnia, and the second figure is the geometry of the brush ice cross section. So as I'm not including some results in even though I have a lot of results already, but I would just like to elaborate on why we are doing this research. The first research that it regards the brush ice, it is the actual models we have now does not include the snow effect on or the snow parameter, and also they don't include also the radiation parameter in these thermodynamic models. So our aim is to include these parameters and validate the models, the accuracy of the models with these 2 extra parameters, as we have concluded from the field work that the snow actually have a significant effect in the thickness and accumulation of this brush ice. And also another why we are trying to investigate the snow contribution in the level ice. We have been looking into laboratory tests, how the snow transformed to slush and further to snow ice. And we are trying to investigate and to somehow validate models with data from cores or data from the vicinity of these channels, because the vicinity of or the ice adjacent to these channels have access to water, and this water flooding the snow reduces the snow and forms ice, which adds extra into the total ice thickness. And it have been hypothesis that it can be a way, by flooding the Arctic region, can be a way to extend the life of ice. So that is the main aim that we have been looking to this phenomena the last 2 years, and I want to thank you. These are some research articles that have been published recently from Luleå University and regards ice research, but we have like 2 more submitted last year and 2 more coming within this project, so thank you very much. Thank you.
Thank you, Vasiola, and congratulations to already 5 publications.
Yeah.
Impressive, thank you. Questions to Vasiola? No? Just a minute.
Yeah.
You will have a cap to wear in the harbor of Luleå.
Yeah, great. I need it. Thank you very much.
Thank you. So our last presenter, welcome, is Ankit Kothari, yes, at Luleå, PhD student at Luleå University of Technology, and the title of your presentation is Concrete for Arctic Regions and Negative Temperatures.
Yes. So, good afternoon. My name is Ankit, PhD student from Luleå Technical University. My project is something like creating or developing a novel low carbon dioxide cementitious binder for Arctic regions. In short, concrete for ecological concrete for Arctic regions. As you all know that greenhouse gas emission is rising where it needs to be at the time when it needs to be falling down. But since we need in order to reduce the emission of this greenhouse gas emission, we need to know from where it is coming and which sectors are contributing the most. In total, we have that 15 billion ton of greenhouse emission is emitting like every year, and out of this, we are mainly concerned about cement because of my profession, and I'm from concrete world, so cement, and cement is in itself is very good from my personal perspective, because we build a lot of like concrete and everything, but it seems to be a very bad guy these days because it is producing a lot of carbon dioxide. Like for every ton of cement, earlier it used to be like 1 ton of CO2, but after many research and everything, now it has been reduced to 0.61 ton for every ton of cement production. And basically, since we need to produce concrete for Arctic regions, when cement comes in contact with water, there is hydration happening and the strength is developed. But this is kind of like related to the temperature. But when the temperature is down, like 0 or -0, the hydration is stopped, or maybe it is like retarded in a way. So what are the consequences? When the temperature is down, we have like a delay in removal of the formwork, which in a way increases the construction cost and production cost. And there is a lot of deterioration, by which we have 20 to 40% strength reduction. And when there is like freezing and thawing, like hot and cold coming like waves, there is durability issues. Again, there is 40 to 60% of strength reduction. And and in a future run, there will be like cracks, spalling, and disintegration. So, are there any options for concrete when you have in a cold temperature? What are the remedies? We have like you can heat the water which you are using and aggregates. Either you can use some enclosures, protective insulations, heating the area where the concrete is placed, or you can add more cement than the required amount, or you can use rapid hardening Portland cement, or the next is like you can use some chemical admixtures which can modify the what do you call this the water. I forgot the term. Like sorry. Sorry, I forgot the term. However, you can use the calcium sulfoaluminate cement. Out of these 5 options, we are mainly concerned about this adding more cement, chemical admixtures, and usage of the CSA cement, because the first 2 options will add on more CO2 emission because of the heating elements. So, what are the aim of this is like preventing OPC usage. This is done by using ecological binder, like using binder waste or industrial waste such as slag, silicon fume, fly ash, And we need to continue the hydration by continuing the, in order to limit the ice formation in the concrete and continue the hydration process, and we need to mobilize the construction waste. So far, these are the publications I have, and out of which this article is quite important and novel, because we created or produced a concrete at -20 degrees Celsius without stopping the hydration, and we continued the hydration with higher strength compared to normal concrete. And this is it, and thank you.
Thank you so much, Ankit. Impressive. Congratulations to publications.
Yes.
So in northern Sweden, we will not only contribute with fossil-free or low CO2 steel, but also low CO2 concrete. I think this is very important contributions to sustainable development of building materials and so on. So congratulations. I'm asked to make some concluding remarks and also say something about ways forward. So, but I would like to start to make a warm thank you to all the excellent presentations and to the audience that has been here and asked questions and really made our day here. And about the way forward, for me, it is only one way forward, I think, and that is together. I believe very much in collaboration and networking, and that we should really try to increase the critical mass of polar research in Sweden. That is actually one goal with this stafette of Polarforum running around between different universities, to highlight polar research as an excellent research topic at each university in Sweden. And here today we have really heard about fantastic research at Lund University, but I also very much appreciated the sessions with excellent research from other university, and not at least the PhD students session. I think that was very inspiring. So I think that it has been shown today that polar research is important for understanding the global environmental change. But it is all very important and has a great potential to come up with sustainable solutions for adaptation and mitigations of the consequences of polar warming that we see so strongly in the Arctic region. So I think polar research has been demonstrated that both for understanding environmental change and to do something about it. And I think that is extremely satisfying to know about polar research. So I hope that you have made new friends, strengthened your networks, and been inspired by the excellent talks today to continue with the fantastic work that you do. And personally, I want to see, I'm looking forward to see a lot of excellent applications to our research councils, VR and Formas, and then how they come into us so that we can help with the infrastructure. And I know that our research councils, they claim that the polar researchers in Sweden, they are so excellent, so they do it so well in the open calls for applications. So just hand in and continue the great work that you are doing.